Well, 21 years after Viking and another lander is now sitting on Mars, Pathfinder. Meanwhile, with me on terra firma is a person who's looked at Mars through the telescope countless times over his long and illustrious career, and no doubt dreamt of events like this, and he's also a great friend of the Open University, Dr. Patrick Moore.
Good morning.
Welcome, Patrick. Now, you've been following the Pathfinder mission over the last 24 hours. Give us a summary. What's the story so far?
Well, we can say straight away that up to now it is a 99% success. What happened is that, as we know, the Pathfinder came into the Martian atmosphere after a long journey through space. It was launched last December. It was braked partly by parachute in the thin Martian atmosphere, partly by rocket braking, and then it was covered by airbags. And when it hit the surface, it bounced as high as a 10-story building, bounced several times, we think, and then came finally to rest, righted itself, and out came the petals. I say 99% success because one of the airbags is at the moment in the wrong place. But there are every reason to suppose they'll be able to dislodge that, and in that case it'll be 100% success. And we have already got the first pictures back. It's an entirely new method of doing things, and I think really before last night, the chances of success were estimated at roughly 50-50. Well, it's been a triumph.
Well, there's great jubilation at Mission Control, because normally they'd orbit round the planet to slow it down, but they've just gone straight in.
They went straight in, and therefore it was a hard landing, not a soft landing, hence the airbag and hence the bounce. And of course, everything had to be purely automatic. In the case of the Vikings, when they went there, you would go into an orbit around Mars and choose your moment to come down with remote control. With Pathfinder, you couldn't.
Well, let's delay no longer. Let's have a look at the first pictures. This is what everybody's waiting for.
That's the picture of the century.
This is fantastic, isn't it?
A red rock-strewn landscape and a pink sky.
Right. And the foreground?
Yes, there we have the red rock-strewn landscape. Remember, the atmosphere on Mars is extremely thin. The air pressure is below 10 millibars everywhere. And although there are winds in the Martian atmosphere, they haven't got a great deal of force. There is a dust storm around. There's nowhere near the landing site.
Now, we're looking at the rover here, aren't we?
We are.
And you can see the problem, can you, on the right of that
You can
picture?
indeed, and I think they can dislodge that quite easily.
Let's have a look at one or two of the others. Now, there is a close-up, a very good picture of what has actually happened here, then, Patrick?
Well, actually, the airbag has come down, as it hasn't deferred quite as it should do. But I think they'll probably be able to tilt it and get rid of it. I suppose in the long run they could actually drive the rover over it, but I don't think that will be necessary.
Let's have a look at the landscape.
The landscape is the area of what we call Aries Valleys, and it was chosen very carefully. It's an old floodplain, probably, the mouth of an old Martian river, and many millions of years ago, water flooded down here, bringing all kinds of rocks with it. And that's the reason why this has been chosen.
OK, and let's have a look at some of the detail of what was washed along all those millions of years ago. There's quite a mixture of hills in the background, large rocks and small rocks. Is this what would have been expected?
I think so, yes. One of the more level areas of Mars, chosen partly for that reason. I mean, there are great canyons up on Mars, we know, and Aries Valleys is one, but this is almost certainly an old floodplain, because there was then liquid water on Mars, though you can't have liquid water there now. And it's a fairly flat area by Martian standards, which is why it was chosen.
Well, we'll be examining those pictures all throughout the morning, and there'll be new ones to come. That is just a tiny taste of things to come, indeed. From time to time, we'll be interpreting this programme. We'll be interrupting it, I'm sorry, to bring you more pictures live from Mars. Now, if you're wired up and online with your own computer, then why not take a look at our website, because we'll be pointing to sites around the world which are also delivering Mars pictures. And of course, a reminder that you're watching Open Saturday live from Mars with Patrick Moore, live in Television Centre. Patrick, what did the world make of Lowell's fantastic discoveries?
Qualified scepticism. See, the canals were first recorded in detail by the Italian astronomer Schiaparelli way back in 1877. He called them canali, translated of course as canals, and Schiaparelli thought they might be artificial. He said in 1889, the suggestion has been made that these are artificial waterways. I am careful not to combat this suggestion, which contains nothing impossible. Then along came Lowell. Percival Lowell, who was originally a diplomat, saw sense, turned to astronomy, founded a great observatory at Flagstaff in Arizona, and equipped it with that very fine 24-inch telescope you saw just now, which I may say I know very well, because in my moon map days I used to observe Mars with it. And Lowell was a great benefactor of astronomer, a great speaker, and a very skilled mathematician. The one thing he wasn't, I'm afraid, was a good observer. And he saw these straight artificial lines on Mars that simply do not exist. And had Lowell's drawings been accurate, then Mars would have been inhabited. But they don't exist, and they don't correlate anything. A little while ago, I took a modern Viking map of Mars, which is absolutely accurate. On it, I superimposed Lowell's canal network, and there was nothing there at all, no correlation. And I must say, when I observed Mars with Lowell telescope, I have done many times, saw no trace of canals.
Well, you have looked at Mars for many, many times. What does it look like through a telescope? I think we have a nice image of it.
Well, you see the white polar caps. There we are. That's a Hubble picture, of course. The white polar cap at the top. Underneath the dark area we call the Mare Aquidalium. And right at the bottom there, you can see a cloud, which I've been looking at myself recently, a cloud over the area we call Hellas. The red areas are known as deserts. They're not sandy, of course. They're dust deserts. The dark areas are not vegetation as we used to think. They're simply areas where the red, dusty stuff has been blown away by winds in the thin Martian atmosphere, bringing the darker material beneath.
Now, there is an irony to Lowell's observations, because all these years later we find out there are indeed channels, or if they're not canals.
Yes, but they weren't things Lowell saw. The channels that have been revealed by the supposed pictures are too narrow for Lowell to see. In point of fact, you know, Lowell very often stopped his telescope down. It's a 24-inch, a fine one, and he used to stop it down to 18 inches, which is an indication that he wasn't a terribly good observer.
Now, we have all these beautiful images from Viking and now Pathfinder. So is there any point to looking at Mars through a telescope any longer?
Yes, indeed. We now, of course, have the detailed pictures from Mars, but don't forget, they can't monitor it indefinitely. I mean, the Pathfinder won't last for long. And in fact, we're making time-dependent observations now. We want to track the dust storms on Mars, the behavior of the polar caps. As the polar caps shrink in the Martian spring and summer, they don't melt. You can't have water upon Mars. They sublime. They turn straight from solid into gas. We're following those and following the various changes that exist there. And also, of course, tracking the dust storms and the wind speeds. And that's got to be done from Earth.
Where is Mars at the moment in the night sky? Can we see it?
In the constellation of Leo, it's getting rather low down there in the southwest after dark, looking like a fairly bright red star. But it's a long way away now, more than 120 million miles, and therefore a ray of light or a radio signal takes 10.5 minutes to get there. So send out a signal now to your Pathfinder. It'll get there 10.5 minutes later.
And that's the pictures, of course,
exactly.
that we're seeing now. Well, thank you very much, Patrick. We'll see you later with our other guests in the studio. Right now, though, we're...
No, it's night there.
It's night at the moment, exactly.
Yes. Night has fallen over various valleys now, and the temperature's gone down below 200.
That's right, and the temperature variation in the long term could be a problem for the rover, couldn't it, because of the huge variation in temperatures?
Well, it could, but of course they've got to recharge the solar panels, and at the moment there are slight problems there that I'm sure will be solved, but there are problems at the moment.
We'll come on to those problems. It's night time at the moment on Mars, so they can't do much. Let's go back to that picture. A bit of data missing on the left-hand corner, but what's interesting here, Dave?
Well, what we've done is we've just moved slightly left of the previous view, and you can see the edge of the petal that the rover has to descend across to get onto the surface. And they've actually targeted the first rock that the Sojourner rover is going to visit, and it's that elongated-looking boulder just above the white of the airbags.
Oh, I see. Yes, the one on the left.
The one on the left.
Boulder on the left.
It's the one that the rover's pointed more or less straight towards. So it's a fairly obvious first target.
It's -15, evidently, the temperature in this photograph during the day. Now, what will they have to do then to free the rover? Because we can perhaps see there the petal and the airbag which is blocking the path for the rover to get off. What will have to happen?
Well, they might be able to tilt it and literally shake it off. But the trouble is it's night there now, and they've got to be able to recharge the solar panels. They've got to be able to have the panels free as possible quite early tomorrow, Martian morning. Don't forget, of course, people probably know, the day on Mars is half an hour longer than ours. So
that's right.
You've got to have a slightly longer night, slightly longer day.
It's called a sol, isn't it?
A sol, yes.
Absolutely. Let's move on to...
667 sols in a Martian year, or 687 Earth days.
So the year's almost twice as long.
Yes, indeed.
Let's move on to the next picture, Dave, and describe what's interesting here.
Well,
it's a close-up, isn't it?
This is a close-up. It was in the distance in the previous view. And the several rocks there I'd really like to get the rover up to, but they all look much the same. But the colours are not very varied. And so we can't tell with these images, are they all the same? The big question for geologists on Mars is what's the variety of rock types? So from colour we can't tell a lot. The probe will analyse the chemistry, but the boulder at the right-hand edge of the screen seems to have a layered structure to it. Not the one with the big shadow, the one to the right of that. You can see diagonal layers coming down from top right towards bottom left. And if I saw that in the distance on the Earth, I'd think, oh, that's a nice layered rock, it's a sediment, it's a sandstone. And so that rock or others like it are obvious targets for a rover, very different to some of the other rocks we can see.
Barry?
one of the things that we are going to be able to do with this particular mission that we weren't able to do with the Viking missions is to look at the images in a lot of narrowish spectral bands. Lots of different filters can be used. And this will actually enable us, using the images, to tell a lot more about the minerals of those rocks than we were with those earlier missions. So that's really going to be a very exciting step forward.
Well, let's have a look at a close-up then at the geological detail. And Dave, perhaps you could say what sort of things we might be able to see from that.
Well,
that's the previous one. The one after this, I think, has some detail. There we are.
Yeah, now, top left of the screen there's a boulder there, and it's covered in pits. Now, we saw several pitted boulders from the Viking lander. The question was, are those pits bubbles from a volcanic lava? Or was it a sedimentary rock made of particles, and particles have dropped out to leave the pits behind? Again, we want to get the rover up to this rock. But the rock, if you look, is perched on top of a layer of grit. And so the rock is protected with grit around it from being blown away by the wind, we presume, which is why the rock is sitting slightly higher than the background. And to the right of that, there's a flattish area, looks much finer grained. Maybe it was mud that's deposited and has now become hard. Again, when we get the rover out there, we'll know.
Lots of questions to be answered, and we hear from NASA there is a problem with communicating with the rover. There seems to be some sort of syncing problem with the information coming back from the rover. So how desperate is that situation likely to be, Patrick?
Impossible to tell at the moment. You don't know whether the trouble is here or on Mars itself or whether they can put it right. I don't personally think it's going to be insoluble. It may cause a delay. But I don't know, but we haven't got the information yet, but I'm still hopeful it's going to be 100% success.
Evidently it's not the hardware, but the software, the communications. But critically, they need to move the rover off the petal, don't they?
They do, because they've got to otherwise the solar panels are concealed, and that'll mean losing power. So don't forget, it is night on Mars now, and it's very, very cold.
And they'll need to charge those petals up first thing in the morning.
With the first fairly early in the morning, certainly. If they leave it too long, because they'll run out of power. That would be, well, not disastrous. It would make the mission a 60% success rather than 100%.
We're hoping for better than that. What is quickly? What are the objectives of this mission to Pathfinder? I noticed the search for life hasn't been mentioned.
No, it's not primarily a search for life mission. In a sense, it's an engineering proving mission. This is a cheap mission compared to what's gone before. But its primary scientific objective is really to establish something about the geology of Mars, the kind of minerals that were there, the sort of things that we didn't really find out about with the Viking lander experiments 20 years ago.
OK, well, let's move on now to examine the evidence for water on Mars in a bit more detail. First, Anna Grayson reminds us what large quantities of flowing water can do quickly.
Well, they should. It's been a remarkably successful first day on Mars for Pathfinder. It landed in darkness, of course. It was a great success. The parachutes worked, the airbags worked. It bounced 3 times on Mars, and then it rolled about 95 metres. And then it came to a rest. It's landed where they wanted in an old flash flood plane. It's level. They've had 1 or 2 small problems to sort out. The airbag didn't fully retract, so they couldn't take the rover off last night at our time as they wanted. But they'll do that tomorrow. And there's a small communications problem between the rover and the lander. But I'm sure they'll sort that out, and there's lots of exciting things to come, I'm sure.
Good news on that score. Mir now, dangerous times ahead for the Russians.
Yes, I mean, the Progress craft that was launched this morning will dock in a couple of days' time. Let's hope the automated docking does go well. There have been problems with that in the past. Obviously, on the ground, cosmonauts are training in that huge wet tank, trying to mimic all of the things that the cosmonauts will have to do up in space in a simulated weightless environment. It's going to be very tricky. I think the first thing to do is to try and restore more or less full power to the station, but with working on the solar panels, and then possibly to attempt to repair the puncture in the spectra module. But a lot of activity can be going on there, and very tricky and very dangerous.
John Mason, thanks very much indeed.
Thank you.